Good morning, good afternoon, or good evening, wherever you guys may be. And today I'll be going over some cross-product exercises. So yeah, let's just get right into it. So if we remembered from my last video, cross products, we're given two vectors, right? And let's say we want to get the vector that's perpendicular or orthogonal between those two vectors. How do we do that? Well, we use the cross product. All right, so number one, let's just hop into it. Number one, we want to find cross product of A and B, vectors A and B. And here we note that A has components 2, 3, 0. B has components 1, 0, 9. So to get the cross product, we're going to do it in this format from last video. 2, 3, 0, 1, 0, 9. And a way we can do this is we're going to format it already in such a way so that we don't have to remember a lot of stuff. So here I'm just formatting it. So how do we do this? We're multiplying diagonals and we're subtracting them. So we start with the I. We're going to delete I and we're going to look at this diagonal, meaning we multiply those minus this diagonal. So what is that? 3 times 9, 27. 0 times 0 is 0. Right? Now we look at J. So we cancel everything that's in J. So that's 2 times 9, 18. 1 times 0 is 0. As simple as that. And then lastly for K, do the same thing. 0, 3. And what do we have here? We have 27I minus 18J minus 3K. And we can denote that as a vector. So this is the vector that's orthogonal or perpendicular. Right? So I'm just going to type that in and see what happens. So we have 27, negative 18, negative 3. Okay. And let's see if we got it. Yep. Okay, now what do we want to do? Next, we want to verify that it is orthogonal. So the cross product that we got, we want to verify if it's perpendicular or orthogonal to both A and B. Okay. So we have the cross product. And we're getting the dot product of A. So we can actually do that, right? So we got our cross product, which is this guy here. With the dot product, we're getting the dot product to vector A. So the components are 2, 3, 0. And what do we get? Well, we get 27 times 2 plus negative 18 times 3. I'm going to put in the other side. Can't see it. Just put it here. Ooh. There we go. And then we add negative 3 and 0. So this will give us 27 times 2, 54. 18 times 3, 54. Yeah, it's 0. And we remember, if the dot product of two vectors are 0, then it means they're perpendicular to each other. So yes, that's 0. And same thing for B, which, yeah, this should also work for B, but we're gonna try it anyways. We're getting the dot product of our cross product and B. 109 for B. And we will get, yeah, so we're doing cross product here. What do we get? 27 minus 27, 0. So both of them are orthogonal. We have verified that they are orthogonal. So they're both 0. Okay. Boom, done. Next. Same idea. Number 2. Actually, remove some. Too many files open. Okay. Okay. Find cross product. Another one of these. Of A and B. So we have A in IJK form. So 5i. So IJK, they're standard basis vectors. And our B is what? 5i minus 5j plus 5k. Okay. And we can actually translate these into vectors. So we're just translating them. We're getting rid of the ijk because we don't want that. Or at least I'm not used to doing it like that. Now we find their cross product. So we go I, J, K, 5, 5, negative 5, 5, negative 5, 5. And now we do our formatting again. So for I, we have 5 times 5, 25, minus 25. So that's 0. J, we have 25 plus 25. Because 5 times 5, and then 5 times negative 5. So minus negative 5, so it's 50. And then for K, negative 25. Negative 25 and 25. So this is negative 50. So you have 0i minus 50j minus 50k. So this is 0, negative 50, negative 50. And we can check. We can get the dot product of this thing and this thing, or this thing and this thing, and it should be 0. If it is, then that makes sense. I'm going to hit this and see if it works. Or I made an algebraic mistake. And you know what? Actually, I'm going to check first before I hit that, before I submit it, because you can actually check, see if it works. So again, we're going to verify that it is orthogonal. Orthogonal to A and B. So their dot product. And this is going to be, I mean, if you guys can mental it, It's really good because I can't. Growing up, I've never really done speed math. So if you ask me like what's 35 plus 100, okay, 135. But if you ask me like 35 plus 897, then I probably can't solve it, right? Okay, so we have 0 times 5 plus negative 50 times 5. Oh, need space. Yeah, so we're just going over some dot products. All right, so 0 times 5, negative 50 times 5 plus negative 50. Oh, look at that, minus 5. That's definitely 0. This is minus what? Minus 250, I believe. Oh, must okay. Yeah, this is minus 250. This is plus 250. 250 minus 250 is 0. And this is just, so this is minus 250 plus 250. This is basically 0. That's definitely 0. So yes, that is orthogonal. We're trying the other one just to be extra sure, I guess. I'm not worried. Answer is 0. We're just checking though. Okay, so components are 5, negative 5, 5 for our vector B. I'm gonna put it here because I don't want to run out of space. And yeah, I can already see it. Same idea. Also 0. This is 250, positive 250. This is minus 250. This is 0. So 250 minus 250, then that's 0. So indeed, they are perpendicular. Okay, I'm gonna hit submit and we can move on. All right, number 3. I think I'm at number 3 now. Okay, so again, we find cross product of A and B, and we're given some interesting stuff here. We're given variables, d6, 1 over d. For B, we're given t squared, 1. And we shouldn't really be too worried because we're just doing it like normal. We're getting their cross product. So I, j, k, d6, 1 over d, t squared, 1. And this is what? I subtract there minus j plus k. Okay, so for our I, so what do we have here? We have 6 times 1 is 6. T squared times 1 over t, that's t. T squared over t, that's t over 1, that's t. So that's 6 minus t. Next, for j, so we have t times 1 is t, t squared times 1 over t is t, so that's 0. And lastly, for k, that's t times t squared, so that's t cubed minus 6t squared. I'm gonna be honest, it's actually quite it's quite easier to do this compared to numbers. At least for me. I prefer algebra than numbers. Okay. So now we can simplify this. So we'll still go with the 60i minus 0j plus t cubed minus 6t squared. Okay. And we make it into a vector. So 6 minus t, 0. t squared minus 6t. T cubed minus 6t squared. Okay, I keep jumbling up my words. Now I have this vector there. I'm gonna plug in and see what happens. So my first component is 6 minus t. Second component is 0. Third component is t cubed. T cubed minus 6t squared. Now I'm going to verify first. That is orthogonal to A and B. All right, so we're gonna try A. So 6 minus t, 0, t cubed. Is it minus? It's minus. Minus 6t squared. And what's components of A? T, 6, and 1 over t. So t, 6, 1 over t. And now we can do some algebra here. So 6t times t plus 0 of 6 plus t cubed minus 6t squared, 1 over t. This is going to be 6t minus t squared plus 0 plus, oh, what did you look at that? This is this minus this, right? Now I can actually simplify that right now. This is t squared. This is 60. So t squared minus 60. Oh, would you look at that? This is 0. Because if you add these two terms, t squared minus t squared is 0. 60 minus 60, you basically get 0. So that works. Now let's try B. So we do the same thing. For B, we have t squared, and 1. Okay, so we have 6 minus t multiplied to t squared. I like putting the parentheses. Helps me organize. I'm going to add it to 0 t squared. And then we have uh, t cubed minus 6t squared times 1. So how would this look like? Well, we have 6t squared minus t cubed plus t squared minus t squared minus plus, tongue twister, plus t cubed minus t 6t squared, which is basically 0. So yes, the vector is orthogonal. Here we're gonna hit submit, see what happens. Okay. Okay. I might be able to do this in one go. Because I only have 8 problems. So I think we can do this in the whole video. So I'm gonna try my best to see. All right. So number 4. If vector A is I minus 9k, I'm gonna translate it immediately to a vector form. So 1i, 0j, negative 9. Okay, here it says B is equal to j plus k. And we want to find, actually, let's do this later. Yeah, we're also going to translate these j and k into vectors. Because honestly, that's easier. I don't want to go through the time of using IJK format. Here we're going to find a cross product of A and B. So first we want to translate this thing. So we have 1 for I, 0 for j, -9. For B, we're getting the sum of two vectors. J is, I believe I is 1, 0, 0. J is 0, 1, 0. K is 0, 0, 1. So we're getting J and we're adding it to K. So we have 0 plus 0, 1 plus 0, 0 plus 1. So we have 0, 1, 1. And okay, now we have these. Now we want to find their cross product. Now this should be easy now. So I'm just gonna do it in this format. So you have 1, 0, -9, 0, 1, 1. And we're going to do the same idea. J plus. So the only way to remember this is positive, this is negative, this is positive. Plus minus plus. This is the only one that has a negative. All right, so let's do it. So for I, cancel out everything in I. So we have 0 times 1 is 0. -9 times 1 is -9. So this is plus 9. For J, we have 1 times 1 is 1. 0 times -9 is 0. For K, we have 1 times 1, 0 times 0. That's it. So we have the vector 9. Actually, let's do this form first. 9i minus minus j plus k. So we have the vector 9, -1, 1. That's it. Nine, -1, 1. All right, let's just do it and see what happens. So, I mean, it's all about, yeah, I got it. So it's all about just breaking it down into pieces, especially those standard basis vectors, IJK. All right, 5 is more of a multiple choice. So we're going to state whether each expression is meaningful. Honestly, basically what's asking if it works or if it doesn't work. That's all it's asking. If not, explain why. If so, if it's meaningful, state whether it's a vector or scalar. So dot product gives us a scalar, cross products gives us a vector. So we're gonna start. Here we're saying, oops, we have this expression here. So the dot product of A with this cross product. So let's analyze. This thing is a cross. Why did I do that? This thing is a cross product. What does a cross product give us? It's a vector. This is what? A vector. We get the dot product of both vectors. It makes sense. So this expression is meaningful. So it's meaningful. And this is what? What does it give us? If we're getting the dot product of two vectors, scalar. We're getting a scalar out of it. So the expression is meaningful. It is a scalar. That's what it is. Let's see if we got that. All right, we got it. All right, let's continue. Same idea. We have an expression. So we have the cross product of A, and this one is a dot product. Now, what is this? Let's look at the one in the parentheses. I'm doing it again. This one is a dot product. B is a vector, C is a vector. So this is a scalar. It's a number. Now, can we get the cross product of a vector, A, and a scalar? No, we cannot. Why? Because cross products are only for 3D vectors. So with changes x, y, z. You cannot get the cross product of a number and a vector. So this is meaningless. If not, explain why. You cannot get the, maybe there's an option here. So this is meaningless because the cross product is defined only for two vectors. Yeah. So the cross product is defined only for two vectors. So cross product only for two vectors. And they could be zero vectors, believe it or not. 0, 0, 0. It works. But yes, that's what's happening here. So yeah. Okay, so it's meaningless. Okay, let's submit, see what happens. If I don't get it, I'm gonna cry. Just kidding. I got it. Okay, next, C. C, senor. C. We have the cross product of A and the cross product of B and C. What does a cross product give us? It gives us a vector. This gives us a vector. This is a vector. So we're getting the cross product of two vectors. So this is meaningful. In other words, it makes sense. And what does this give us? If we get the cross product of two vectors, we get a vector that's perpendicular to both these vectors. So it gives us a vector. So this is meaningful. And it's a vector. All right, I accidentally hit the answer for letter D, so I'm also gonna do that. Can't go back now. So for D, we have this time the dot product of these two guys here. Right, we have two vectors here, B and C. We get the dot product. This gives us a scalar. And can we get the dot product of a vector and a scalar? No. So this is actually meaningless because of the dot product. Meaningful. I swear. My mind is thinking one way. I'm saying something different. Mouth to mind error. Okay, so this is meaningless because the dot product is defined only for two vectors. Yeah, so I'm gonna say like dot product only for two vectors. Can't be a scalar. All right. Let's hit submit and see what happens. So as I'm going, I'm trying to hit submit. Okay. E, letter E. Oh, look at that. So we have the dot product of two vectors here, and then C and D. So what's happening here? We have four vectors, A, B, C, and D. We're getting the dot product. So this actually gives us two scalars. This thing's a scalar. This thing's a scalar. In other words, it's a real number. Can we get the cross product of two scalars? No, so it's meaningless. For cross products, we need exactly two vectors. I keep saying meaningful. I meant meaningless. Cross product only for vectors. Only for vectors. So this is meaningless because the cross product is defined only for two vectors, right? Okay, let's just answer the last one and for this item, this problem, I mean. Okay, so we have the cross product of two vectors, and we're getting the dot product of that to another cross product of two other vectors. Does this work? So this gives us a vector. This gives us a vector. We get the dot product of two vectors. We get a scalar. So this is meaningful. Now I'm going to write meaningful. Yes, I need my brain to function the same way as what I'm saying. What do you call it? The mind and body connection? Okay, meaningful. So this gives me a scalar. Gives me a number. So it's meaningful. The expression is meaningful. It is a scalar. Okay, we're gonna hit submit and see what happens. Hopefully I don't throw my monitor. And we got, okay. Now we want to consider, I'm gonna write number 6 first before I say anything. We want to consider the parallelogram. Parallelogram. With vertices. So we have vertices. Amazing. Oh, would you look at that? It's in 2D. Uh, A, which has components -3, 0, B, which has -1, 3, and C and D. C, which has 5, 2, and D, which has 3, -1. So usually these are where the harder ones come in. Or probably puzzles. I don't know. Oh, fine. This is an interesting question. We want to find a vector AB and AD. A B as in boy, AD as in Dunkin' Donuts, writing each. Oh, would you look at that? Writing each of these vectors as a 3D. So that's interesting. Yeah. How do we do that? No idea. I'm actually gonna test it out and see what happens. Okay, I'm gonna try it out first, and if not, I'm gonna ask for help. But I think what this is doing is basically this. So AB, I'm going to check these changes here, and I'm gonna add a Z, which is basically 0, because there's no changes for Z. So this is -1. How do I get from -3 to 1? Obviously, I add 2, right? So -3, -1 minus -3, -1 plus 3, that's 2. So that's the change in the x part. So that's 2. Yeah. So from A, I add 2, I get to B, which is -1. And then here from 0 to 3, what do I do? Obviously, I just go to 3. I just walk 3 times to get to 3 from 0. Now for my change in Z, it's just nothing. So that's it. That's my AB. I'm actually going to check, see if I got it, but not super confident. So 2, 3, 0. Probably going to hit submit and see what happens. Yeah, it's a 3D vector. Let's see. That's my intuition though. Oh, I got it. Nice. Good intuition. And same for AD. So we're doing the same thing. We're tracking that change in D from A to D. So 3 minus -3, so that's 6. From -3, I add 6 to get the 3. From 0 to -1, obviously I just subtract 1 and 0. So that's that. Done. Got that part. I'm actually gonna check, see if I got it. 6, -1, 0. Hit submit, see what happens. Nice. Now I want to find their cross product. So now we want to find their cross product. So we're just going to use that IJK format that we did. So IJK 2, 3, 0, 6, -1, 0. Oops. Okay. So what do we have here? I minus J plus K. Subtract, subtract, subtract. Now, let's get rid of I. 3 times 0, so this is all 0. Let's get rid of J. I'm not going to get rid of it anymore. 0, 0. And for K, -2. Ooh, -2 minus 18. That's -20. So 0i, I'm just gonna, so 0, 0, -20. That's the vector. Right? All right, let's see. So 0, 0, -20. How do I check? I just get their, actually, can I mental it? Let's see. Can I get their dot product and see? 2 times, sure, one of them. 6. Ooh, that's interesting. Wait, I probably got it wrong. Or am I just doubting myself? 2, 3, 0, 6, 0. Take out the I, so 0. 3 times 0, 0. -1 times 0, 0. For J, 2 times 0, 0. 6 times 0, 0. For K, 2 times -1 is -2. 6 times 3 is 18. -2 minus 18 is -20. So we have 0i minus or plus 0j, 0i plus 0j plus -20k. So we have 0, 0, -20. I forget the cross product though. Oh no, that's all 0. Because you just multiply 0 to -20. So yeah. Okay. So that works. I'm gonna hit submit and see what happens. So I like hitting submit because I know math comes in steps. So if I don't get the first one, I probably won't get the other ones right. Okay, the last thing we have to do for this problem is to find the area of the parallelogram, which is actually easy because you just have to find the length. So what I'm saying is if you're given a cross product and you get the length of it, that's basically the area of parallelogram. That's it. So I just have to get the length of the vector that I already have. So I'm getting the length of this thing. So that's 0 squared, 0 squared, -20 squared. So that's 20. That's it. All right. Um, okay. 2 more numbers to go, and we're gonna finish it. Number 7. So we want to consider the points below. I'm gonna write the points below, don't worry. So points below, we have 3 points actually, P, Q, and R. 1, 0, 1. For Q, we have -2, 1, 3. For R, we have 3, 2, 3, 2, 5. Okay, what's our first question here? We want to find a non-zero vector orthogonal to the plane. To the plane through points P, Q, and R. So how do we do this? Something about cross products, obviously. We're imagining, right? P, Q, and R are in the same plane. So let's say like these are P, Q, and R in like some points here in the XYZ plane, right? This in and of itself, they're kind of like on that plane. Now I don't know what plane this is, but they're all like there in that plane. And so I want to find a vector that's orthogonal to those, to the plane, basically perpendicular to the plane. And so how do I do that? Well, I just get their vectors, right? And then I'm going to use the cross product because I want to get their perpendicular vector, right? So we have like, let's look at it in 2D. We have, let's say, points P, Q, and we have like what, some R here. We want to get like this thing here, that vector, and this gives us perpendicular, and these are all in that plane. So what does that entail? This vector here in green, I'm changing it to green, is also perpendicular to this plane, not just to these points here. And it has to be non-zero. Okay. So what I'm going to do is do a cross product of PQ, vectors PQ and PR. So first I'm going to find what PQ is. PQ is, well, we look at their changes, right? So we have -2 and 1. How much does it take to get the -2 from 1? So -2 minus 1 is -3. So 1 minus 3. So this is -3. 1 minus 3 is -2. From 0 to 1, that's 1. From 1 to 3, that's 2. See, mind and body connection is not connecting. All right, we have PR. So this is 2, this is 2, this is 4, I believe. Unless I wrote my points incorrectly. Okay. Yeah. Now I want to get the cross product of those two. The idea here is gonna highlight. I always do that. I like highlighting. Is to find cross product. Now I think it could be any. They should work because they're in the same plane anyway. So any of them should work. We're just using this because it's the typical example. All right, so we do that IJK thing. So this is -3, 1, 2, 2, 2, 4. And here we have, well, we're going to format it. So I minus j plus. I need to put on the other side. Let's put it there. Plus k. Subtract, subtract, subtract. Right, so for I, we have 1 times 4 is 4, 2 times 2 is 4, so that's 0. For j, -3 times 4 is -12. Ooh, handwriting is not handwriting. We're subtracting that to 4, because 2 times 2 is 4. Okay, and then we have, for k, -3 times 2 is -6. 2 times 1 is 2. So this is 0i minus, what is this? -16, so plus 16. Minus -16, minus 8k. So now we have this vector here, 0, 16, -3. This is a non-zero vector. And we can check by just getting there. Yeah, this gives us, yeah, these are definitely perpendicular. I did the cross product in my head. Okay, this works. Let's see. So you have 0, comma, 16, comma, -8. Now I'm gonna hope this works. If it doesn't, I'm gonna check. Cool. Okay. Because the next question is related. Got it. Nice. Okay. Next thing we have to do is find the area of the triangle. We want to find area of the triangle PQR. How do we do that? Well, we already have the vector, right? If we get the length, so if we get the length of some cross product here, we get that area of parallelogram, which is basically the area times the height. And then what if we just divide by 2? The area times the height divided by 2. If we divide by 2, that's the area of the triangle. So we basically get the length and then divide by the by 2. And then that's it. Okay, so you want to get the length of the cross product divided by 2. So we get um, 16 squared negative 8 squared divided by 2. What does this give us? 16 to itself is 256 plus 16. We got 272. Square root of 272 over 2. That's it. Can I simplify, make it cleaner maybe? Maybe divide it by 4. Okay. Yeah, I can do that. So we actually have 68 square root of 68 because this is 4 times 68 to 68. Cancel the 2's. Can we simplify it even more? Oh my gosh, we can. So this is what is this? 4. So 2 square root 17. But that's just me being aesthetic. I'm gonna leave it at that. There we go. That's the area of the triangle. So 2 square root of 70. So let's plug that in and see what happens. Boom, nice. No, crap, I didn't get it. Find the area. Okay, I'm gonna see why I got it wrong for now. Yeah, I did the exact same thing that it's looking for. Just minimize. Okay, what happens? Oh, that's interesting. Because I did the exact same thing. And I don't know why. Yeah, 1/2 of the length of the cross product. That's what I did. I don't know why I got it wrong. Yeah, see, 1/2 of the length. What's the length of? All right, did I mess up? 16 times 16. Because I got the first one. That's 256. 8 squared. 256. Oh, 256 plus 64. So that's 320. I thought 8 squared was 16. I was thinking of something else. Anyway, this is it. The second time, I'm not gonna simplify it. That's all good. So square root of 320. Let's see if you got it. I divide that whole thing by 2. Yeah, right? Wait, let me double check. Something about my solving. 256 plus 64, 320. So it's square root of. There's no way. Is it divided by 2? Yes, because that's the area of the triangle. We divide the area of the parallelogram by 2. Okay, let's submit and see what happens. Nice, finally. I'm kidding. Okay, last question, and then I'll call it a day. Oh, my screen is acting weird, but anyways. Okay, last question of the day. So we want to again consider points below. Great, now my OneNote's malfunctioning. So consider points below. And so what is this? We have B -3, 0, 6. We have Q, which is 1, 4, -2. We have R, which is 0, 4, 4. Cool. Okay. Now, what's our first question here? We want to find a non-zero vector. Orthogonal. Why do they use that word? I might have to look it up. Why do they have perpendicular and orthogonal when they could just call it perpendicular? Then I heard from my professor, there's going to be 3 names for the same word perpendicular, but I guess they're used for a certain reason. Okay, so find a non-zero vector orthogonal to the plane through points PQR. So it's actually the same idea that we went over. Through points PQR. So it's the same step as earlier. Yeah, it's the same step. They just made the numbers different. All right. Let's go through that same step again. So we want to find the cross product. It's also for me, getting practice, you know? Because in math, it's all about getting the practice. If you don't get the practice, then... Anyways, 1 minus -3 is 1 plus 3, so that's 4. 4 minus 0, that's 4. -2 minus 6, that's -8. So these are the components to get from P to Q. For -3, you have to add 4. For 0, you have to add 4. And for 6, you have to add -8 to get the Q. Now PR is the same idea. So 0 minus -3, it's 3. 4 minus 0, it's 4. 4 minus 6, that's -2. Yeah, and actually the fun thing about these vectors, or the tricky thing the tricky thing about these vectors is order matters. So if you mess up one order, then not gonna work. Like I could I could do RP. This is not the same as PR. Those are not the same. They don't have the same components. Anyways, so you have 4, 4, -8, 3, 4, -2. Right, so let's do that trick. I like this trick. This is what our professor taught us. It's really quick and easy. We add it. Okay. And we cancel. So I'll just do it. So 4 times -2 is -8 minus, or actually plus 32, because 4 times -8 is -32. For J, we have 4 times -2 is -8 again. 3 times -8 is -24, so plus 24. And lastly, for K, for K, 4 times 4 is 16 minus 12. 4 times 3 is 12. And we get a vector out of this. We get 32 minus 8 is 24. We minus 24 minus 8 is 16. So minus 16. So this becomes 16, but because of the minus becomes -16. And this is positive 4. Oh, I was drawing with the eraser. That's that cross product there. Oops, sorry. I actually simplify this, divide everything by 4. I'd still get the same thing. just a matter of rescaling. But I'm not gonna do that. No need to. Okay, I'm gonna type this in, see what happens. We have 24. We have -16. We have +4. And hit that submit, see what happens. And boom, I got it. I almost said I didn't get it. Manifesting. Okay, B. Because, yeah, B. Here we want to find the area of triangle. I should have just written triangle area, right? Area of triangle adds the off. Anyways, so PQR. So we want to get the length and divide by 2. Yeah, also in cross products, order actually matters. Yeah, just pointing that out. Okay. So we do IJK here. What am I doing? Oh my God. I meant get the length. Okay, so we have our vector here, right? And we get their lengths. So you have 24 squared. Okay, I probably should have scaled it. Anyway, let me divide that by 2, whatever that is. Now I have to go through the pain of doing this. Okay, I'm gonna do it. So 576. 16 squared is 256. This is 16. Square that thing. Square that thing. Divide that by 2. Yeah, all right. 16 squared. Yeah. And then 24 squared, just to be sure. So I have big numbers here. 576 plus, I just add them. 848. Well, big number. Divide that by 2. And that's it. See if it works. So we have square root 848. You divide that by 2 and hit that submit. See what happens. Now I probably didn't make any arithmetic errors. Hopefully not. Okay, we got it. Okay, so that's that for cross products. And yeah, thank you guys for watching. I'll see you guys in the next one. Oh, I hit transcript. Okay, I'll see you guys in the next one.